Hello students, I am Anamika and in this video we are going to discuss arithmetic progression. So what is an arithmetic progression? When a sequence is called arithmetic progressions or AP. So a sequence A1, A2, A3 up to AN and so on is called arithmetic sequence or arithmetic progressions if AN plus 1 is equal to AN plus D, where A1 is the first term and D is the common difference between the terms. So, if A is the first term, then again D is the common difference, then the second term will be A plus D. If A plus D is the second term, then what will be the third term? That is A plus D plus D. Since D is the common difference, so it will be A plus 2D. So, A plus 2D is the third term. Again, if we want to write the fourth term, then it will be A plus 2D plus D, that is equal to A plus 3D. So, A plus 3D will be the fourth term in this sequence. So, if we are asked to find the nth term of the AP, then we will have the formula A plus n minus 1 into D, where we will represent it as AN. So, if we are asked to find the term, that is, for example, we are asked to find the 17th term. So, it will be A17 is equal to A plus 17 minus 1 into D, where A is the first term and D is the common difference. So, after that, if we solve this equation, we will find a value which will be the 17th term of this sequence. Again, we have represented as L, where L is the last term. If the AN is the last term, then L is equal to A plus n minus 1 into D. So, if we are again asked that we have a sequence that is A plus D, A plus 2D and so on, and we are asked to find the sum to n terms of AP, then we will just add all the terms, that is A plus D, A plus 2D, A plus 3D, A plus 4D and up to A plus n minus 1 into D, since it is the last term. So, if we can see that there are n numbers of A present in this sequence. So, we can if we just common A, we will get n into A, because there are n numbers of A present in this sequence. So, it will be n into A plus, we can see that there are n minus 1 numbers of D present in this sequence, that is n minus 1 numbers of common difference present in this sequence. So, it will be, if we will write it, we can write it as D plus 2D plus 3D plus up to n minus 1 D. So, if we take common D, then we will have 1 plus 2 plus 3 plus up to n minus 1. So, here we have a formula that if we have a series that 1 plus 2 plus 3 plus up to n, then it will be n into n plus 1 by 2. That is the sum of the series, that is 1 plus 2 plus 3 up to n. It will be n into n plus 1 by 2. So, here what is that? Here n is n minus 1. So, it will be n minus 1 into, that is n. Again we have n plus 1. Here n is n minus 1. So, it will be n minus 1 plus 1 divided by 2. So, we can cancel it out and it will be n into n minus 1 divided by 2 D. So, if we want to simplify it, then we will first take common n from the equation, that is n will be outside of the equation, then n, and we will count take common 2, 1 by 2, then it will be n minus n by 2, and here it will be 2A plus n minus 1 into D. So, here if we can write it as also we can write it as n by 2 a plus n minus 1 into d. So here we have written then that a plus n minus 1 into d is equal to L, that is the last term. So it will be n by 2 plus n by 2 into a plus L. So where L is the last term. If we are in the question, if we have the last term, we will use this formula to find the sum of the n term. So we have this formula and this formula and this one also. So let's come to the next slide. So we have some of examples, and we will first solve that is it arithmetic progression or not. So our first example is 2, 4, 6, 8, 10 and so on. So what is the first term in this sequence? Here first term is 2, that is A1 is 2. So again we can see that our second term is A2, that is 4. So A2 is 4. Again A3 is 6 and A4 is 8. So if we are asked to find the common difference, what will be the common difference in this sequence? So common difference is, for example, our first common difference is D1. Let us assume the common difference is D1. Then D1 will be A2 minus A1, that is 4 minus 2. 4 minus 2 is equal to 2. So our first common difference is 2. Again, if we are asked to find the second common difference, that is D2 is equal to A3 minus A2. Then it will be equal to 6 minus 4. 6 minus 4 is 2. Again, if we find D3, we will get 8 minus 6, that is equal to 2. So here all the common differences are same. So since the common differences are same in this sequence, so this the sequence which we are given is arithmetic progression, that is arithmetic sequence. In our second example is 2, 4, 5, 8, 9, 10 and so on. So what is the first term in this sequence? Can you tell me what is the first term of this sequence? So here first term is A1, that is 2. Again, what is the second term of this sequence? That is 4. So first of all, we will find the first common difference, that is D1. What is the D1? D1 is equal to A2 minus A1. So here D1 is equal to A2 minus A1, that is 4 minus 2, that is 2. Again, what is the third term? Third term is 5. So what is the second common difference? That is D2. D2 is equal to A3 minus A2, that is 5 minus 4, that is 1. So thus D2 is equal to D1? No, the common difference is not same. Since the common difference is not same, then this sequence is not arithmetic sequence, that is D2 is not equal to D1, thus this is not an arithmetic progression. So our third example is 1, 3, 5, 7, so on up to 31. So can you tell me what is the first term? Our first term is 1, that is A1 is equal to 1, A2 is equal to 3, A3 is equal to 5, A4 is equal to 7, and our last term is L is 31, that is A1. Let AN is equal to 31. So first of all, we will find common difference, that is D1 is equal to 3 minus 1, that is 2. D2 is equal to 5 minus 3, that is 2. Since the common difference is same, so the common difference, let D is equal to 2. So if we want to find how many terms are present in this sequence, we will use the previous formula that we have discussed, that is this formula. So we will use it, that is AN is equal to A plus n minus 1 into D. So we are asked to find how many terms are present in this sequence. So first of all, we will write the value of AN, that is 31. 31 is equal to, what is the first term? First term is 1. Then 1 plus n minus 1 into d. What is the common difference? Common difference is 2. That is 2. So we are asked to find the value of n, that is the number of terms present in this sequence. Then we will solve it, that is 31. We will take in 1 in left hand side, that is minus 1, then n minus 1 into 2. Then is equal to 30 equal to n minus 1 into 2. We will divide it 30 by 2, then n minus 1. N minus 1 is equal to, if we divide 30 by 2, that is equal to 15. Then n is equal to 15 plus 1, that is 16. So there are 16 numbers of terms present in this sequence. So we can find the value of n by using this formula. So our fourth example is 2, 4, 6, 8, 10 up to 48. So what is the first term in this sequence? Can you tell me what is the first term? First term is 2. Second term is 4. Third term is 6. Fourth term is 8. And we can see that the common difference is same, that is 2, 2, 2. So the common difference is 2. So here last term, that is L is equal to 48. So can you tell me how many numbers of terms present in this sequence? So we will use this formula, that is n is equal to a plus n minus 1 into d. So we will put the value of n, that is last term, that is 48, and we will put the value of a, that is 2, and plus n minus 1 into what is d? D is 2. So we will solve it, and তোমালোকে এটো সলভ কৰিবা আৰু কমেন্ট সেকশনত কবা ইয়াতে কিমানটা টার্ম আছে সো লেটস কাম টু দা নেক্সট স্লাইড তোমালোকে এটো সলভ কৰি কমেন্ট সেকশনত কবা কিমানটা টার্ম আছে ইয়াতে সো এক্সারসাইজ 9.2 so we are asked to find the sum of odd integers from 1 to 2001 that is 2001 so first of all we will write the some few of odd integers that is 1, 3, 5, 7 and up to 2001. So can you tell me what is the first term? Our first term is a1 is equal to 1 and common difference is 3 minus 1 that is 2. So we are asked to find the sum of odd integers. So first of all we will use this formula to find the number of terms present in the sequence. Then we will use this formula, that is first we will find n and then we will put the value of n. Then we have already have the first term that is 1 and we have the last term that is 2001. So we will then simplify it. That is first an is equal to a plus n minus 1 into d, that is 2001 is equal to, what is the first term? First term is 1, then n minus 1. What is the common difference? Common difference is 2 into 2. So it will be 2001, we will take 1 in left hand side, that is minus 1 is equal to n minus 1 into 2, that is 2000 is equal to n minus 1 into 2. So we will divide 2000 by 2, that is equal to n minus 1 is equal to 1000 and we will take 1 in right hand side, that is n is equal to 1000 plus 1 is 1001. Then we will use this formula, that is we have already find the number of terms present in the sequence, that is 1001. Then what will be the sum of odd integers, that is Sn. Sn is equal to 1001 by 2 into first term. What is first term? First term is 1 plus what is last term? That is 2001. 2001. Then into 2002 divided by 2. So we will first divide this by 2, that is 1001 into 1001, that is 1000 whole square. And if we will solve this value, that is if we multiply this, that is 1001 into 1001, we will have 1002001. So the sum of odd integers from 1 to 2001 is 1002001. So our second question is, how many terms of AP minus 6 minus 11 by 2 minus 5 and so on are needed to give the sum minus 25? So we are asked to find the how many terms will be needed to give the sum minus 25. So here we already have Sn is equal to minus 25, and here the first term is A1 is equal to minus 6 and D is equal to minus 11 by 2 minus 6. That is minus 11 by 2 plus 6, that is 1 by 2. And we have discussed a formula in previous slide that Sn is equal to n by 2 into 2a plus n minus 1 into d. So here we already have Sn, that, and first we will write the formula, that is n by 2, 2a plus n minus 1 into d. So here Sn is equal to minus 25 and n is not given, we are asked to find n. Then what is the first term? First term is minus 6, that is minus 6, n plus n minus 1 into d. What is d? D is 1 by 2. Then we will solve it. Minus 25 n by 2 and it will be minus 6 if we multiply it by 1 by 2. Then it will be n minus 1 into 1 by 2 into 1 by 2, that is 1 by 4. Then if we multiply n, that is 6n, and if we take LCM, that is 4, then it will be 24, and it will be n square by 4 by minus n by 4, that is equal to, we will multiply minus 25 by 4 to simplify it, that is 100, equal to minus 24n plus n square minus n, that is minus 25n plus n square, and is equal to n square minus 25n plus 100 is equal to 0. And if we factorize it, we will have n minus 5 into And if we factorize it, we will have n minus 5 into n minus 20. So is equal to n is equal to 520. So there are maybe 5 numbers of terms are needed to give the sum minus 25, or there are 20 numbers of terms needed to give the sum minus 25. So n is equal to 5 or 20. So that's all for today. Thank you, students.